We are about to start. We're just waiting another minute as a lot of people are still joining us. We have quite a full program ahead of us. All of you have been very, very busy this week and in the past few weeks as well. Preparing for this hackathon, we've had some amazing results. We are looking forward to presenting our 10 finalists. At the same time, congratulations to all of you who finished all the deliverables of this hackathon. The ideas were all really, really good. It was really hard to make this choice. I think that our jury members are going to stretch that as well soon. I am here with my colleague Michele Erba from Pristine Agency, who has been, as many of you know, quite instrumental in the creation of this hackathon. I am Angeliki Karampourouni from Seascape, Belgium, and also part of the Blue Cloud 2026 consortium. We are also joined by Emina Mamaca, a representative from DG RTD, Research and Innovation. Thank you very much for being with us, Emina. As you know, the Blue Cloud project is supported by DG RTD, and of course, without your support, we would not be here today. So we would like to actually start with a few words by you. So I will give you the floor. Thank you.
Yes, thank you, Angeliki. Thank you for inviting me. Of course, I'm happy to be there with you to present a few words on the Blue Cloud Hackathon. This is an initiative of the European Union that brings, of course, together innovation, but collaboration and shared commitment to the future of the ocean. It is very a major event because as it's designed to demonstrate how digital technologies and open science can accelerate the transition toward a sustainable blue economy. And I'm very happy that I heard that for this session of Blue Hackathon, more than 1,000 people were registered. This is a great success, wonderful, bravo, where we say in French. And with very diverse people, I heard, yes. For us, it's a very a nice living example of a co-creation space where I think there is students and there is a researcher, of course, there is entrepreneurs and innovators from across Europe and beyond join forces. I can say that using the Blue Cloud platform is to federate the ecosystem of marine data for computing resources and, of course, analytical tools for us. It turned data and knowledge into a practical solution, but scalable solution, which is very important. They also address some key EU priorities like climate adaptation, ocean health, biodiversity protection, and sustainable use of marine resources. But of course, for us, it's not only a competition. It's also a demonstration of European values with open science, with international cooperation, with digital innovation, of course. And this is also a collaboration between sciences, industry, and policy for us, because the hackathon directly supports the European Union major priorities like the European Green Deal, the EU digital strategy, of course, and of course the mission restore our ocean and waters by 2030. This is a really creative young minds with the guidance of experimenters, of course, and the participants tackle challenges that matter deeply to all of us, protecting biodiversity, supporting climate resilience, ensuring sustainable fisheries, of course, and driving a driven and responsible blue economy. What can I say more is that there is a multidisciplinary teams which will transform scientific knowledge and data into practical solutions. And this is very great. The Blue Cloud Hackathon is a sort of a launch pad that not just for ideas, but also for solutions with impacts. And it embodies the belief that Europe's leadership in science and innovation must serve a global purpose, of course, a healthy ocean for future generations. And more globally, what I can say is that hackathons are important. It's an important instrument to stimulate innovation and collaboration in Europe. Why important? Because they accelerate innovation. they accelerate innovation, they foster interdisciplinarity, they build capacity and talent, and they engage citizens and raise awareness, and of course strengthen European cooperation. Then I can just say one thing more, that just let's continue.
Thank you so much. This was really great. To be honest, I think that if we hadn't already finished the hackathon, we'd make a video out of it and invite even more people to participate. Indeed, the engagement was great, and
Yeah.
I think that you've touched upon many things, but especially your mention of open science and the digital innovation. I think that these are all at the heart of Blue Cloud 2026. And so very important components of part of what we are trying to achieve here. So thank you so much again for your support. And indeed, this is the best way that we can kick off with this award event. And I think that I hope that all the participants today understand how much we truly appreciate the work effort that they have done. Thank you very much, Emina. All the best. And I guess we look forward to other such opportunities. Thank you again.
Yes, thank you. Thank you for inviting me. And I have to leave because I was in a meeting and just go out and I go back again. Then thank you. And bonne continuation. Let's continue.
Merci. Okay.
Bye.
Bye. We are going to hear a little bit more about the resources that were used, as well as we'll get a little bit more of an overview of that last few days and some of the results from other aspects of this hackathon. A bit later during this event, we're going to hear from our colleague Sara Pittonet from Trust IT, who is the project manager of Blue Cloud. A lot of you have met her during our first live session, I believe, but Sara will rejoin us once we hear the pitches. So now we are going to start the pitches. First, we're going to introduce our incredible jury members. We have a great panel of jury members that have already reviewed, they have had a chance at the first review of your ideas. And this is how we have now the 10 finalists. We have Marco Filippone from Fugro, representing the blue economy. We have Dave Mills from Bangor University in research and academia. We have Osman Cherkaoui Tagaki from an ECOP from Morocco Steering Committee. We also have Mary Maliset, a colleague from Mercator Ocean International, who is quite the expert on editor. And we also have Elisa Ravagnan with us from Norse, who's an expert on a variety of subject matters of the topics that we have been covering today. I would also just like to especially thank Elisa for being with us today and for going through the entire review process. Elisa is not feeling very well, but she is with us. She will follow all of the pitches as well. And some of our other jury members will be asking questions on her behalf. If I may, I would like all the jury members to please open their cameras and join us. And hello, Dave, Mary. We also have Marco, I believe. Hi, Marco, and Othman. Okay. And we're going to start with a round of introductions. If you could please introduce yourself. We can start with Dave.
Well, good afternoon, everyone. Pardon me. It's a great pleasure to be here and to have been able to look across the fantastic range of ideas being brought forward. Truly exciting to be involved. So my background is in marine science and oceanography, and I've ended up back at the university where I first did my first degree many years ago. My career has really spanned everything from collecting water samples, looking at phytoplankton down a microscope, to sort of launching the robot. So really, I've ridden the wave of that sort of digital marine digital revolution, and finally ended up working with European funding to develop the blue economy around marine renewable energy, particularly tidal range and tidal stream devices, and other approaches, novel approaches to grow the blue economy in Wales. So I'm looking forward to playing a part in this process, and hand over to my next
Thank you.
referee. Thank you.
Thank you, Dave. Really looking forward to your questions. I know they will be very, very good. Marco, hello, please. We cannot hear you very well. No.
Let's try again now.
Perfect.
Very good. So again, good morning, good afternoon, evening, everyone. My name is Marco Filippone. I'm the Director, Hydrography Ocean Science for Fugro. My background starts with the Naval Academy. So my background is maritime and nautical science, developed in advanced degree in hydrography and oceanography. So I served within the Navy Hydrographic Office for about 10 years before joining Fugro. And in November will be year 11 for me in Fugro. So my track records mainly span from large-scale mapping programs, but also developing and implementing technologies. And nowadays focusing on the integration of those technology, data fusion, and leveraging AI for let's say, well-known applications. So I'm very excited to be part of the jury member today, and looking forward to hear more on those fantastic projects. And I wish everyone good luck.
Thank you so much, Marco. Thank you also for being with us today. Thanks. Mary, please go ahead.
Hi, hello, good afternoon, everyone. Thank you for having me in this Blue Cloud Hackathon jury. I'm very excited to be here. So I'm Mary Malissé. I'm working for Mercator Ocean International that is located in Toulouse in France. Mercator is the operator of the Copernicus Marine Service and also the coordinator of the Digital Twin Ocean Editor project. I am myself the project manager of Editor Model Lab, which is the modeling side of Editor, working on the next generation of ocean models using supercomputing, AI, and developing application to be made available on the Editor platform. So I would be very interested to see how Editor can be useful for your work, especially in Challenge 4, Editor Challenge. I'm not a scientist, so I also take this opportunity to thank you all for your efforts to vulgarize, to make accessible your very technical daily work, obviously. And congratulations already to all for the great work and very interesting ideas and project you have shared with us. So thank you.
Thank you so much, Mary. And I think that a lot of the topics that you've been working on Model Lab are where the features that a lot of our participants were looking for, and we do look forward to seeing how some of them managed to implement some of that. So let's see how that is. I believe Othman is trying to join. There's a bit of a problem.
Angeliki, he's trying to join. Yes, he will
Okay.
join us for the questions. Yes.
Great. So I believe, however, that we can already move forward because we have a lot of ground to cover. So I think that we can start with the first pitch of the first idea. We have, as I mentioned, 10 finalist ideas that are going to present today. They will give us their pitch, and this is going to be followed by questions that our jury members have prepared individually for each team. Once this process is over, all of our jury members and Michele are going to leave us for a little bit, and they're going to go and have a final deliberation in a separate breakout room, make final decisions, and then they will come back and announce the winners. In the meantime, us all together with also with Sara Pittonet, we're going to look at the mini challenges. That it was another wonderful aspect of what you did. So without further ado, let's please start with our first pitch. So the first team that we're going to be looking at is the team MusselAlert, stress risk alert system for mussel farms. This was challenge for the wildcard, and they doubled up with Editor.
We're Team MusselAlert, and our idea is an early warning system from Mediterranean mussel farms called MusselAlert. So now the problem is that in recent years, mussel farms of the Mussel Mytilus galliprovincialis in the Thermaikos Gulf of Greece have suffered repeated crises, peaking in a devastating almost 90% harvest loss in 2024. The thing is that farmers lack a real-time, easy-to-use tools to anticipate risks, and that's because current data streams are too complex and scattered.
Our solution is to create a lightweight app that transforms data from Editor into clear, actionable alerts for the farmers. We can source data from Editor like water temperature and salinity, and as well as applying species-specific biological thresholds to alert farmers for any danger. It turns complex ocean data into plain language alerts and suggestions of proper actions.
So this is our notebook in the Blue Cloud Lab, and what it does is it combines historical marine heatwave data with Edido, current real-time sea surface data, and forecast to create a risk score that works like a traffic light, where green is good and orange or red is bad. In conclusion, MusselAlert helps protect aquaculture livelihoods in the face of climate change. Thank you for your attention.
Okay. And with us, we have representatives. I see another Angeliki. Hello. Welcome.
Hello.
And Nikhil, how do you do?
Hello.
And of course, you are one of the 10 finalists because we really like your idea. So let's so we would like to hear your pitch.
Our team actually focused on the Thermaikos Gulf because, well, I am from Greece. I heard from last year's the news that there have been massive losses on harvest and both seed stock. This is why we decided to make a tool that will predict that will predict and also take data from Editor and use them to alert the mussel farmers. The idea is that
If you don't mind me jumping in here. So what we decided to, so the problem that we found was that mussel farmers often will not be able to look through all of this data and then, see that, hey, there's going to be a heat wave coming up, or the water's going to get too salty for the mussels. And we don't want all of them to die, all of these mussels to die, because that would create like huge economic downfall and it would cause a lot of problems. And so what we've decided to do is we are using data from Edido and also from the marine environmental indicators to kind of create, to help us create like a risk algorithm that could feed into like a very simple like app that would alert these mussel farmers that, hey, it's something's going to happen. You should take some action here if you want to save your mussels.
Okay, thank you very much. Let's invite our jury member to ask their questions. I believe the first question is going to be asked by Mary.
Well, thank you very much for this presentation. It was very clear. I was just wondering, what are your plans for the upcoming month in terms of uptake to further evolve your proof of concept? And also, in case you win, how would you plan to use the award monetary resource to upscale your solution?
Could you clarify what you meant by uptake for the next month?
How you plan to develop your project, your concept, to make it to engage people to use it in the near future,
I see.
that kind of actions in the next few months, for instance.
Sure. Right. So right now, what our proof of concept does is that it just takes in sea surface temperature. And what we want to do is we want to expand that to other biological thresholds that could also threaten the mussels, like for instance, salinity or dissolved oxygen or chlorophyll A. So our first step would probably be to expand our product to also incorporate these other factors. And then we would have to actually connect it to an app and then probably pilot it with some local farmers in the area. Oh, and also actually on the flip side, we need to add in our marine environmental indicators data because that helps create a baseline for when it gets too hot. After that, it's just piloting it, checking in with the farmers, making sure everything's okay, making sure it doesn't false positive or give too many alerts, or if it doesn't alert, see if it actually helps, if it actually predicts dangerous conditions for mussels. And then after that, it's just further scaling. Maybe we could add in biological thresholds for different species or for more locations other than just like the Thermaikos Bay.
Might I add to that we were thinking that we might use some pilot farms to compare with farms that don't use the tools, so we can determine if it's actually worth it and if it needs something to change, or for us to take in other factors besides the ones that we already have used.
Thank you very much for those clarifications. Thank you.
All right, excellent. Okay, if Mary has no other questions, if anyone else, if none of our other jury members have any questions, I don't think so. Okay, Dave?
Just a quick question from me regarding how you would validate the outputs from your tool.
So what we output is kind of like a traffic light thing. What do you mean by valid? Because ideally what we want to ask the mussel farmers if these were accurate assessments. Because what we output is kind of like a traffic signal of like, hey, it's getting hot. And so ideally we would be able to test like if it is hot when our program says it's hot. But that would only come from close collaborations with local mussel farmers and also possibly testing of our own.
Okay, thank you for that.
Of course.
All right, thank you, Angeliki, and thank you, Nikhil. We will come back and let's see how it goes for your team, but it was definitely an excellent idea and we really appreciate it. Okay.
Yeah, of course. Thank you so much.
Bye-bye.
Thank you. Let's go to the next team. It is the algae alpha signals. They are part of Challenge 2. They're supporting early warning and response to accidents or natural events. The Alpha Squad. Let's see their video.
Algae alpha signals are an innovative system. It's an agentic AI system that predicts and alerts macroalgae overbloom in the Mediterranean. It transforms actually economic and ecological disaster in opportunity, because by sending the signals to the coastal authority together with a plan for the anticipation of the arrival of the patches can still have economic value because this is biomass. So our signals are crucial to this end-to-end solution to actually transform the hazard and the problem into economic opportunity. We implement a revenue split, but simulated, and all the data from a lot of data from Lab 1 and 4, and we also upload it in Edito. We are compatible with smart cities, and we're looking forward for the next chapter of this. The time was short, but we are very, very happy with our success of all implementation for now.
Sorry, Tom, I didn't see your message earlier, but it was a very good video and we have to show it because it was part of the review. And apparently the jury members did like it. So here we are.
Good. Yeah. Thank you for that. No, but we had another video prepared, but last minute we had to replace it with a quick pitch.
Don't worry.
We're here now, and we're very happy to be here.
Okay, and I believe that the jury member appointed is Dave
Yes.
Mills. So with us we have Tom de Blok and Matthias Ferrer, who are going to answer all your questions. Please go ahead.
Yes. So if I can just take, so I will pitch it quickly. So we had a multidisciplinary team over 9 people, 5 countries. It was very it was challenging to be remote and so on. So as we said, our problem here is microalgae overbloom and the coastal events. They have a very big economical and ecological impact. Economical because if it goes on the beach, the tourists cannot be on that beach, so the municipalities need to clean it and so forth. And ecological because of greenhouse gas and so forth. It's also a missed opportunity because when it becomes fresh on the beach, it's no longer the biomass that can be worked. While if we signal it earlier, and that's the concept of algae alpha signals, is that we have an early warning and response system. It's multi-agent AI that signals the arrival of the microalgae and enables actually coastal authorities together with solution providers to anticipate the arrival, to keep it there as a biomass, to harvest it, and so it creates actually out of a problem, it creates opportunity. So we used 2 labs. Lab 1 and 4 was big hassle. We can provide a lot of feedback on that. And also we use ingestion on words editor because the signals, so just very briefly, the prediction actually predicts that because of the values, we suspect algae overbloom to happen in this area. Then we move to another agent for classification based on satellite images. Here we were struggling not to have annotated images. So we did unsupervised learning, which in alternative if you don't have it available. And so this classification agent then would confirm the patch, and then we moved to the lab 1 for the current, and that was a big learning for us because you have a thing called new to us but maybe familiar to all of you is Lagrangian simulation. You can use it forward in our case to predict where it's going to land on the beach, and backwards if we would have more time series. That's maybe something for later, to actually learn where a coastal patch came from and maybe learn from the route it followed. But that part was poorly developed. It's not developed, but it's a future perspective. So our pilot was in the Mediterranean. And so our alpha signal, as I said, it's sent to the coastal authority. It's important to mention that we are FIWARE compatible standard. It's a smart city component. So ports and smart cities that use FIWARE, most of them in the world use that or are interoperable with it. So we have interoperability with coastal authority, dashboards, and so forth. And we ingest editor because I think these signals are useful for many. And a very important thing to mention also that we have a very innovative reward system. And maybe that's something very important to potentially all the implementations is the concept of co-creation and revenue split. So when the coastal authority rewards the signal, we simulate €100 settlement and split it towards data provider, AI aggregator, and the solution providers.
Okay, thank you, Tom. We need to go. Thank you. It was part of your deliverables, and we need to go to the questions.
Yes,
Yes.
Yeah.
Please go ahead.
Was done.
All right. Okay, Dave, please.
Great, thanks for adding further information to that. It sounds like a very timely and exciting project. What do you regard as the biggest source of uncertainty in this very complex system that you pulled together? And how would you communicate that?
The source of uncertainty, I think, is the availability of valid data sources, but maybe I will give the speak to Matthias.
Yeah, the data source is one thing, and also the weights that we are allocating to the different data that we have. For example, the system architecture that we present is 4 steps: detection, prediction, alerting, and publishing. And in the detection, I've been selected a weight into the TRIX score for a 40%, 30% of chlorophyll concentration, and 30% of oxygen depletion. That is our type of level that we use to measure if there is algal bloom into the ocean. So I think the uncertainty comes here, and we need to validate really in deep how we use these weights and how we achieve this description. This multi-parameter approach gives us around an 84% accuracy into detecting the blooms before they become visible.
Okay, thank you for that. Just a more generic.
I would like to add the unavailability of data sources as a problematic thing that we want to. I mean, there is some data sources are told to be there, but when we try to consult them, they turn to crash or be empty, and it's a concern. So quality data is crucial to this kind of system.
A final question then: how far advanced is this, let's say, idea? I mean, are you still at a research phase, or do you have a working prototype?
We have
how far along are you? Sorry, Karen.
We are TRL 3 between 3 and 4. So we have a working prototype. We advance it. We have an academic validation, and we also have business validation. We also found funding opportunities, so we definitely go forward with this. It's a real case. It's not it's TRL 3 and above.
A really cool feature that I don't want to forget to highlight is that during the alerting, we are creating a system that is tamper evident using cryptography. So in a way, we are using a blockchain. In the demo is a tamper evident blockchain, but we want to pass to a tamper proof evident alerting system, and that way, if an event happens into a threatened area, we could directly incentivize the people to donate directly to that incident and directly divide the amount of money collect or whatever into that event, and you can erase the previous events because you're gonna modify the hash. So I think it's a really cool idea for transparency into these donations when the economic impact happens, not even for the alga overbloom, for every natural impact.
Thank you very much.
Okay. Thank you very much, Dave. Thank you also.
It was a great experience. Thank you for everything.
Matthias
Thank
and
you.
Tom. Thank you so much. And all the best to your team as well.
Thank you.
Thank you.
Okay. Now we're going to go to team number 3. This is another challenge for team DTO meets animal movement, mapping marine movements in the North Sea, the TwinTrack. Let's take a look at their video.
Skates and rays. Elasmobranchs of the North Sea are vulnerable species, vital for ecosystem balance but threatened by fishing and climate change. To protect them, we need to understand how they move, when and why. Tracking fish movement is key for science, conservation and sustainable policy.
We combine tagging and telemetry with fisheries catch record and plankton data as a prey proxy. Using Blue Cloud and editor services, these inputs are harmonized and fed into the movement model.
Built during the Blue Cloud Hackathon 2025, this prototype will scale to more species and finer data, a powerful decision-making tool for Europe's oceans.
This digital twin empowers researchers, managers, and policymakers. It can guide marine protected area design, assess fishing pressure, and anticipate species shifts under climate change. In short, it turns complex data into actionable knowledge.
The result is a digital twin of fish movement forecasted across space and time. Our interactive viewer lets users explore tracks, environmental drivers, and predictive corridors with continuously updated data.
Our team brings together marine biologists and data scientists, working with Blue Cloud VLabs and editor services during the Blue Cloud Hackathon. Together, we're bridging field data with cutting-edge digital tools.
That was an excellent video. Thank you very much. We have Lotte Paul with us from the team, as well as Christopher Monk and Marco. This is a team that you're going to be asking questions of. Do you, Lotte or Christopher, have something to say before we move on to the questions?
Yeah, if you like, we can extend our idea again.
Again, well, yes, of course. If if something that you would like to add additionally to what you have already presented, but I think it's a good idea so that the other teams can have an idea as well. Please.
Okay, perfect. Thank you. Basically, what we're trying to achieve with our proof of concept that we developed during the hackathon is that we want to bridge the gap of animal movements not being represented in digital twin applications at all so far. And that also predictive modeling of animal movements, which is very important for ecosystem health, is really at the start still. So we take the relapse of Blue Cloud, and we combine that with the services from Edito to really try and bring all of this to the next level by creating this interactive viewer where people can actually select individual animals that were tracked in the North Sea, and they can predict themselves using different settings that they can decide on. And we also feature environmental layers such as bathymetry, but also human use information like wind farms or shipping. So this, in the end, is supposed to be a well-rounded application that people can use to better understand where animals go, also in view of different climate change scenarios, and then try to plan and manage ocean spaces accordingly.
Thank you, Lotte. Thank you again. It's clear that the jury members also thought, and our coach and mentor teams thought it was a great idea. And here you are also at the 10 finalists. So I'm going to now give the floor to Marco.
Yes, thank you. Again, very, very well articulated. I just have a question. If you could maybe provide how you see the project moving forward in terms of scalability, giving a bit of a preview how the roadmap will be looking like in the event of an award, or if you anyway wish to continue with this project at different geography, just to clarify a bit that part, that would be great.
Yeah, thanks, Marco. And thanks for the invitation in the finalist panel. And it was a great experience to join the Blue Cloud Hackathon. Basically, at this point, we have a proof of concept of the functioning. So we have a kind of toy model of the skates. And the idea now is to start to ingest more data and basically bring in more predictive layers. And of course, this was constructed over a short time period, so we also need to, of course, improve the usability of the visualization app as well. And our idea as a team is that we would work in the North Sea because it's a place that's very data rich right now. So as we bring in more species and more data layers, it kind of can serve as an example of where we might take this in other basins as well, and bring in other basins into the Edito platform.
Thank you.
Okay, great. Yeah, replicability is always a feature that we're looking for. Do any of our other jury members have any follow-up questions? No? Not for now. Great. Lotte and Christopher, your deliverables were quite complete. It is true. So thank you very much, Marco, and thank you to your team. I wish you all the very best as well. And we're going to move on to the next team.
Thank you.
Thank you very much.
All right, now we have a team from Challenge 3 of tracking and forecasting ocean health, the Smiley axolotl. Yes, that is the name, I believe, of the project, and it's Parviflo, where, when, and why the O may flip before it does. Let's watch the video and we'll hear from them.
Listen. This isn't just water, it's food security, climate, and the pulse of our coast. But as waters warm and oxygen falls, small pelagic fish get squeezed and jellyfish take over. Hence, Parviflo. And we are Team Smiley Axolotl, a group of students from KDG in Antwerp who study applied computer science. We all gathered here to develop Parviflo. So, what exactly is Parviflo? ParvyFlow is a rapid response early warning tool. It streams open ocean data such as temperature, oxygen, chlorophyll, and some other data from Blue Cloud services and fuses them into multiple outputs. As you can see here, we have a map with different points. All of those points are just specific locations on the map where you can pick. As you can see here, you can either pick it on a map or input specific coordinates. Then you'll get some information about the location, about the change in the jellyfish and plankton population, information about the dissolved or inorganic carbon context, and about sea surface salinity. And for the nerds in the audience, of course, we have a public repository with all of our files that you can go and visit and check for yourself.
All right. That was great. That was Smiley axolotl team. We have with us Daniil Mumladze and Alina Dimova. Dimova. Please join us. And this was another team and idea that all of our jury members liked. But Elisa Ravagnan specifically wanted to ask you some questions. Since she cannot be with us, we have asked Othman to fill in. Hello, Othman Cherkaoui. When you do open your microphone, you may also introduce yourself, since you had a little bit of problem connecting in the beginning. And then we can move on with the questions. I would like to ask first Daniil and Alina. Is there anything that you would like to add, something you'd like to briefly describe, perhaps the idea? Please go ahead.
I think I want to sum up idea again in a short. So basically, we try to develop a platform that tracks how there's a change in the fish and jellyfish population and also about the plankton, because of course they're all interconnected, and if one of the ecosystem starts to grow too fast, there's a problem in the entire ecosystem. So that's what we try to solve by using Blue Cloud data and some external data to put it all in one pipeline. And also one of the main ideas what we wanted to do is to make this public and available to everyone, because I think that research should be available to anyone. Any student and any researcher should be able to access our platform. That's why we made it a web application. So any person can just open it in any part of the planet and use our model in their own specific area. So that's what I wanted to add a bit.
Thank you, Daniil. We did mention open science in the very beginning at the heart of Blue Cloud as well. So this is wonderful. All right, let's go to our questions. Othman, please, and welcome.
Thank you so much, and I'm really sorry. I had trouble connecting. That's the thing of live
sessions.
Yeah, live session. That's the trouble having live session. But I would say I'm Othman, and I'm a jury member. I'm also have a PhD in mathematics, applied mathematics into fisheries, and also I'm like one of the ECOPs, the young professionals that like to do a little bit of everything. Yeah, so we loved the project, and I especially loved the project. Yeah, and I have one of my questions and also one of my fellow jury members' question. So one of the questions that was raised is, you've said that you're kind of applied computer science, all of you are applied computer science, and we were wondering, have you thought about including marine biologists with you to give you more feedback?
Yeah.
Because that was the most thing that we had as a
Yeah.
discussion. And my second questions, it would be on the line of that, by adding one, do you have any understanding of the next steps, 3 to 6 months, budgeting and things to assist us see the scalability of this project?
Yeah, thank you for your questions. They're actually like very important to us as well. We were trying to include some people from marine side. For example, there's a big university in Antwerp that actually studies marine biology. There are a lot of people there. So if we win and we keep continuing working on this project, we would of course love to include some people in the industry to help us. For your second question, I forgot the second question.
The second question was
like
the future. Yeah. So the future would be, of course, to collaborate with the Marine University of Antwerp to find some people there or across the world as well. We're open to work with anyone. And of course, we want to make this application public and accessible to anyone. So that will take some time to adjust our pipeline and to make it deployable. So anybody can access it without like big latency, because of course it's a huge model that takes a lot of data and a lot of pre-processing. So if it's not optimized well, it will not be a good application for people and researchers to use.
Okay, thank you so much.
Thank you.
I would also like to add something. Can you hear me?
Yes.
Yeah.
Okay. So basically, regarding the program units that we use biology, chemistry, and physics. We had deep research about that. From the biological side, we use jellyfish occurrence data from JD as like warning signals of imbalance. We combine these plankton distributions representing both the food base for fish and the competition dynamics with jellyfish. On the physical side, we integrate salinity data from climatology WOA18, which is a key environmental driver of species distributions. And on the chemical side, we bring carbon chemistry, dissolved anorganic carbon, to capture stressors like acidification. And we connect all these data sets together. It was really hard work into a prediction model, which correlates biodiversity patterns with salinity and carbon indices. This model aims to forecast where and when the jellyfish arrivals are likely to increase, which is crucial, which gives us a window of months for early response that we can forecast.
Excellent, excellent. It's great always when the questions of our jury members align with things that you wanted to say, of course.
Of course.
Thank you all three very much, and all the best to your team. Smiley Axolotl, very interesting name. Okay, we are going to go to the next team. Here, I'd just like to quickly mention, I do see that there have been a couple of hands that were being raised. I'm so sorry. Due to the nature of this event, and because we do have a lot of content, we are not able to allow this feature. But we do hope that we can answer questions or comments at a future opportunity, perhaps. But please do feel free to put questions in the Q&A. We'll see how we can address them. Okay, now we're going to go to our next team that we're part of Challenge 2. They are the RugOBSS, and the topic was invasive macroalgae observing beach cast system. Let's take a look at their video.
Invasive macroalgae species that form huge biomass accumulations on beaches can cause enormous damage to biodiversity, local economies, and culture, outcompeting local organisms, smothering aquaculture and fisheries nets, and engulfing natural heritage sites. The invasion of RugOBSS okamurae in the Strait of Gibraltar has been causing economic, ecological, and social losses for 10 years, which continues to spread throughout the ocean. To fight the struggle against these invasive species, our team has been studying in the last years how to map invasive macroalgae across Europe, using satellite imagery and creating a ground truth dataset to scale up a monitoring solution that helps public authorities, private companies, and people. Within the Blue Cloud Hackathon 2025 Challenge 2, we created a proof of concept to integrate satellite observations with Blue Cloud services by modeling the marine ecosystem variables and the local oceanographic dynamics during invasion events identified by the RugOBSS algorithm. Combining these open access data is essential to predict future events and provide information on biomass, coastal conditions, and arrival time, facilitating effective management and decision-making, leveraging the Blue Cloud environment from the regional knowledge to a prediction solution.
Okay, another, again, excellent. You guys created some really good videos. With us, we have Mar Rocamora, and I'm sorry, Bede already. We also have Bede.
Bede.
Bede. Ro Davis with us from the RugOBSS, and Othman is going to be asking the questions. Before we move to the questions, would you like to say a few words on your project, on your idea?
Sure. So our group is a group of oceanographers and computer scientists, and we are more on the side of research, open research. So the idea of this, we developed a proof of concept to check if we could monitor first through Earth observation the RugOBSS okamurae, that this is this invasive species that we've been tracking in the south of Spain since 2020. And we already have a proof of concept here locally, and we want to scale up this solution with our own database that we created through all these years by also like combining the modeling to forecast where it's gonna end up. And so also the municipalities can know when it's coming, so they can take it from the sea before it's beating, because also the ecosystem under the sand is affected. And also the ministries have the data to compensate economically these damages.
Excellent. And we mentioned replicability before, but scalability is another very important feature for any such idea. I'm going to give the floor to Osman.
Yeah, thank you so much. Yeah, I have also a couple of questions. One question is, I feel like most of the project didn't go in depth with, is like, what are your KPI milestones in the next 3 to 6 months, looking ahead for the growth of this project? And however, my second question is a bit, by me understanding well the project, it felt like you already had a concrete EPO tooling that was working before, and now you're either reusing it or making a novelty to it to push it ahead. So this is where we were confused. Were there, because previously you mentioned that there was like a published example slash, and now are you reusing it or you have novelty added to it for this project? Yeah, thank you.
Yeah, so thank you for the question. So that was like the first proof, local. That was 3 years ago, but right now we have a bigger database and we have much more information. And we were looking for the platform where to like apply it for the Earth observation by making these novelties in the new RugOBSS algorithm, that it is how we call it, to first detect it and then use the modeling, all these databases and the virtual labs to use the forecast, because we know where the algae is, so we can go backwards and study where is it coming from, that we know is from rocky beds, but then improve it with the modeling that the Blue Cloud and the Edito platform can leverage.
Okay. And what about the 3 months ahead, the KPIs, you're going to push the milestones, the 3 to 6 months ahead?
Yeah, so maybe I can talk about that a little bit. So as Mar said, there's sort of the two model layout of having sort of observation or imagery and prediction model that then is used for prediction using sort of currents and dynamics into the future. So the first element of that will be developing the RugOBSS model itself and making sure that that's validated using independently sourced data from across the region. But then also inputting that into the forecast model will then also need its own validation in itself using the forecast model. So I think, yeah, a few months into the future, it'll mostly be focusing on the observation event model, and then sort of looking to 6 months, maybe a year ahead. That would then be when we would start to use that information for predictive or current dynamic modeling.
Okay, thank you so much.
Excellent. Do any other of our jury members have any questions? I believe not. Thank you all three very much, and all the best to your team as well, Bid and Mar. We are going to go to our next team.
Thank you.
Thanks very much.
Thank you. Yes, and this one is Octopulse. Kraken the code. It's a very great, I felt it was a great team name. So this was part of challenge 2 again, of supporting early warning and response to accidents or natural events. Let's please go to the video.
Hi everyone, I'm Molly and I'm here today to bring you some breaking news.
In the southwest of the UK, there has been a huge boom of octopi, and it's been reported in everything from national, international, regional news.
What we don't know are the drivers that are causing this to happen.
Objectives: 1, to progress science to build up the understanding of what causes them, and 2, to be able to explain the impacts of this to regional planners. So who are the users? As I alluded to, we have two main elements. The first objective is for marine experts, so scientists, fishers. Doesn't have to be a scientific expert, for people who really know the sea.
So what we've got here is a tool where we can use science democratically. We can look at all of these different potential drivers, and people can almost vote on what they think are going to be the main drivers of these blooms. And from this, we're able to carry out what-if analysis. We can take these drivers and we can see what happens to the blooms in these situations.
Latest wisdom is used to create a risk map, which can be used by marine managers to take high-level action to capitalize on the presence of these animals. It's been quite well spread throughout the Blue Cloud ecosystem. And some next steps: this has been an incredible hackathon, a really useful way to develop some key features. We'd like to point out that this is a reusable framework, not just Octopi. You can bring together scientists and non-scientific communities, develop understanding, and communicating that knowledge is an important factor that can be applied to a wide range of uses. Thank you.
Thank you so much, Kraken the Code team. With us, we have Molly James and Benjamin O'Driscoll, and Marco is going to be asking the questions. Of course, it was an excellent idea, the way that you presented the breaking news, and you two have used, again, one of these important punch words that we're looking for. The reusable part of your idea could be valuable. Would you like to say a few words?
Yes, yeah, I'd be quite happy to do so. I just want to check that everyone can hear me okay.
Perfect.
Excellent. Okay, so first I just want to start off by thanking the judges for getting us this far into the finalists. We really appreciate that. And also to the coaches who were able to help us along the way, because I think it's safe to say we use your knowledge a lot. So we really enjoyed the challenge. We really welcome the opportunity to use the Blue Cloud services to pull various data sources like Earth observation and in situ into our Octopulse tool. So we thought that the seamless integration between those services and existing resources like CMMs and eModNet really worked well. So well done, first of all, for designing that system. But to break down our tool, I think it's really there's three parts to it. So firstly, it's this idea of a historic lookup. So when we have these octopus booms, we want to present the information to the users so that they can see what parameters might actually combine to kind of encourage these booms. So we want to pull information like sea surface temperature, turbidity, ocean currents. So the first thing is a dashboard to bring all that information together with some user interface widgets so that they can determine things like date and exact geographical lat long positions. So that was the first part of our tool. I think the second part, which is really important to stress, is this idea of collective intelligence. We recognize the value that scientific information can bring, but also it's about how we combine that with users who really have an understanding of what these of what's going on at the ground or sea level as it should be. And this idea of collective intelligence is about combining all of the parts together, but actually getting something that is bigger than those individual components. So that's where we're trying to move this. The final part is this top level policymaker. So the top level policymaker, they just want to see a quick dashboard that gives them a threat level, whether the forecast is predicting one of these booms, so that we can be best prepared to responding to that, whether thinking about mitigation. So I think one of the key things to stress, and Tom does it in the video really well, but I think it's really applicable, and actually from watching the previous videos, I think it's really important to stress this. What this is actually a framework. So there's no reason why our focus is on octopus, because that's impacting us in the local region. But actually, I can see us collaborating with lots of the teams that have got into this finalist panel about applying this to other species of interest. So I think that could be a really exciting way forward to us. So yes, thanks for the opportunity, and welcome any questions.
Thank you very much. Thank you, Ben. I'm going to give the floor directly to Marco to ask the questions.
So I think Ben made my homework pretty easy. but let's maybe try to reformulate the question. So mainly, in a nutshell, I was about to ask how we could repurpose or scale it to other application in the way I was reviewing the documentation and the video before. Obviously, we were addressing a problem, or let's say one topic that was in my, I mean, I'm not an expert of this particular topic, but I had the impression that was recurring every 50, 70 years, and therefore could have been a one-off effort to develop such analytics and platform to create insight around. So that indeed my question was to you and the team, how that indeed, what's the plan beyond being capable to capture that event every now and then. If the event is simply the tool will improve the way we can actually monitor wider frequency, or let's say a different frequency of those events, because we can then have a better grip of the data and the science behind. That was mainly first part of the question. Or the idea is let's focus on this and then we can increase the scope where it makes sense. So that is my question.
Okay, so I'm happy to give it a go. Molly, I don't know if you've got anything to add, but I'll happily give a first go to that. So
yeah.
I think, oh, sorry. Okay, so lots of I think the main focus is this idea of an early warning system. So again, it's like lots of the groups have talked about. So our focus, and as you rightly picked up, because we have that infrequency of these booms, it's really about how can we be best prepared so that when parameters or these influences come together again in the future, how we can be best prepared to do that. So that forms the second part of this tool, which is the collective intelligence. So, for example, Molly's work links the ocean currents about how the larval forms migrate north into our waters, and how we might want to weight that depending on the local knowledge that we get from our user base. So hopefully that answers your question, Marco.
Yeah, just to add to that as well, I think that the basis of this being sort of a framework of a tool rather than a tool specifically for the octopus booms is a really valid argument for its use, because obviously, like you said, these octopus booms we're seeing every 50, 75 years, it doesn't need predicting quite so often, right? But if we can use the same principles to monitor other stuff, then the usage of it just like massively grows, right? With the octopus stuff in particular, it's really good to be able to know about these things, because we're finding the aquaculture industry over here just isn't prepared for it at all. So you've got people that are going crabbing, they're not getting crabs, but they're taking in all these octopus, but they can't sell them because the infrastructure isn't there for them to be able to process them properly. So having some sort of predictive tool, even if it is for a one-off event, means that they would be able to plan that in advance.
Thank you. Very clear to me. I say he partially already answered my question during the pitch. So thank you very much for validating that once more.
Thank you.
Thank you.
Thank you all very much. And I have to say to the Kraken, the code team that also the Alpha Squad team would like to be able to get in touch with you and further discuss and actually collaborate if possible. So we're going to make sure that we make this happen after this event. We're going to connect you, and you guys can see how perhaps we can move things forward together. Thank you very much for the presentation. All the best to the Kraken, the code team.
Thank you.
And yes, we're going to move to our next team now. Okay, updating the Mediterranean outflow water indicator through a workflow study using multiple data sources. This was once again a team that was part of Challenge 4. They used a double up with Editor Wildcard. The MedSea investigators, I believe that we have with us Marjan Finlayson and Damiano Del Rosso. I'm so sorry for the name thing. And the questions are going to be asked by Mary, and I believe that Dave also has some follow-up. Let's first take a look at their video.
We are studying the long-term changes in the MOW core in the North Atlantic Ocean to update the MOW indicator, which currently extends to 2020. By using temperature, salinity, and dissolved oxygen products at about 1,000 meters in the MOW reservoir, we're extracting data from the Beacon Data Lake in Blue Cloud and from the European Digital Twin Ocean Lab. We have explored our in situ observational data in our studio and our Python Jupyter notebooks to see the frequency and shifts of our variable concentrations over time, primarily looking right now at maximum salinity and minimum dissolved oxygen concentration. We are also processing products within the Edito Data Lab using the Jupyter Notebook platform to interact with our Edito process data to our Beacon data on the Blue Cloud platform. If you are a researcher, policymaker, blue economy professional, or a mariner, you should download our notebooks to track MOW variability in the North Atlantic Ocean.
All right, great. It's always good to have videos that have a call to action in them. We have with us Marjan and Damiano. Welcome.
Hello.
Thank you.
We're also joined by Mary and Dave. Before we go to our jury members, would you like to say a few words?
Yes, thank you. Just wanted to make it clear, thank you so much for having us on the Blue Cloud Hackathon. It was really exciting. And wanted to explain that one of the key processes that we wanted to accomplish with this work was to demonstrate how you could use Blue Cloud and Edito platforms to speed up scientific processes by not actually downloading data sets and like analyzing them on a local platform, but rather remotely, which makes it easier to do a multi-product approach when doing different scientific processes and to actually include real-time indicators in our research. So that was a big component. That's stuff that we're working on a local platform. So we were excited to apply it to our remote work using the Blue Cloud Lab and Edito as well.
Thank you so much, Marjan. I cannot stress enough how much we really wanted you to achieve exactly what you did. So that is a great result for us as well. I'm going to give the floor over to Mary and Dave now. Mary, please.
Hi again. So thank you very much for this presentation. We have again the same question, but we are all wondering. So what would be your plans for the next few months in terms of uptake, development, further evolving of your proof of concept, to scale your solution, to grow your solution, to serve the users, and also what would you be planning to do with the award money if you win? Thank you.
Thank you for asking. So our next steps right now are to continue with the analysis so far. This is something that we're really, again, like updating using in situ data and also introducing the reanalysis data at different resolutions. We want to further explore the data in Edito particularly to see how that actually would merge with our in situ data, but also like having a full understanding of how the resolutions look differently in terms of gridding and everything else. And then to compare that with the already existing indicator that exists is for the marine outflow water reservoir at this moment, looking again at temperature, salinity, and dissolved oxygen products. That's our big thing right now, and going forward to also introduce why this data is important to do on a remote platform rather than local and publish this data going forward. In terms of our users, we would like to really scale this for our people within the physical oceanography realm who care about climate science and also students and researchers, but also introducing this as something important for blue economy professionals particularly. And of course, trying to find a way to connect with fishers and folks in that nature. In terms of the prize money, Damiano, do you have any, would you like to add on to that? I think for us, we'd like to just continue forward with trying to push the data on and to add to this work, because we're from the same institution, essentially we'd want to do more work with this data and do more things focusing on remote work. Damian, I don't know if you wanted to add anything.
Yeah, about my plans for the near future, I would like to optimize the code to make it faster and lighter, to exploit all the possibilities that editor is offering, and getting more and more familiar with this tool, which is very, very powerful. So these are my plans for the near future.
Thank you very much. Very clear. Thank you.
All right. Dave, please.
Yeah. Great to hear about your project, and interesting to see you diving into physical oceanography. So it sort of stands out from the rest of the challenges. If I understand it correctly, what you're doing is coming up with a new improved way of calculating your indicator, MOW. And as I understand it, the MOW has been in use for some time prior to your program. So you have a time series, potentially, let's say, adjusted by the addition of a new way of calculating MOW. Is it the same as the previous one? And how do you know? And if not, does that in fact reduce the length of your time series? You're starting a new time series because it's a new MOW. Hope that's clear.
I think so. In terms of this, so far, what we've been able to do is just look at our in situ data so far to get an idea of what that would look like, the time series so far. Our plan to go forward would be similar to what was done with Copernicus in terms of using the indicator to apply the same climatology removal to see what the different anomaly looks like to get a kind of index like they'd done before. But we would do this more into the future, if that answers your question.
So you're establishing a new indicator from this point in time.
New, but updating on the previous.
So if you were measuring, okay, so by analogy, if you were measuring temperature for 100 years and you came along and stopped using a mercury-based thermometer and used some sort of electronic device, you might expect that you're not measuring the same thing.
Right. Right. So for the previous one, they would have used salinity. So in this, what we'd be looking at is maximum salinity as well as dissolved oxygen. So it would look a little differently in that way. So if that is helpful, but also temperature, we're interested in that as well. So does that answer your question, Dave? I'm not sure if that was.
Yes. I mean, it seems to me what you're saying is that you're establishing a new methodology to derive an indicator of value.
Yes.
But it's not the same as the previous sort of estimate.
We just have a few more data inputs.
Correct. Okay. No, I think that's fine. That's answered my question. Thank you very much.
Thank you very much. So yes, they're looking to improve maybe. That's always good. Thank you so much, MedSea investigators, as well as Mary and Dave. Very good luck to your team as well. And we're going to go to our next finalist. Okay, yes, it is the Blue Cloud Marine Early Warning System. Their team is Blue Cloud Marine. They were part of Challenge 2. Let's first watch the video.
Hello, everyone. We are Blue Cloud Marine, a team of researchers and data scientists from Qatar, Spain, and Colombia addressing Challenge Number 2, which is supporting early warning and response to accidents and natural events in our oceans. As we all know, global change is shifting how species migrate, threatening fisheries and food security. Oil spills and extreme weather events risk damaging ecosystems and aquaculture. Current responses are often reactive, leaving communities and economies vulnerable. So our solution is the Blue Cloud Marine Early Warning System. By leveraging Blue Cloud Virtual Labs, Copernicus Marine, Amadnet Biology, and EYES vessel tracking, we integrate oceanographic indicators with machine learning for predictive modeling. Throughout the hackathon, we designed the dashboard, integrated datasets, and developed the notebook to ensure reproducibility. In this case, our dashboard delivers key performance indicators, real-time alerts and risk assessments for species migration, aquaculture, weather alerts, and an oil spill monitor. The system transforms marine management from reactive to proactive. It reduces economic losses, prevents ecological disasters, and supports sustainable fisheries. Our scientific approach combines data integration, advanced analytics, and real-time visualization to empower stakeholders and decision-makers. This was Blue Cloud Marine Team, turning data into action for safer oceans. Thanks for watching.
All right, this was another truly excellent video, and the idea as well behind it. It is the Blue Cloud Marine Team, and I believe with us we have Laura Ballesteros. Laura, if you can please join us. And the questions are going to be asked by Osman and Dave. And we're going to wait a little bit for Laura to join. Or Michele.
Or me, exactly. So yeah, I'm asking Laura to start the video and audio, but here she is. Hi,
There
Laura.
she is.
Hi there.
You are muted, Laura.
Hi, good afternoon. How are you?
Hello, thank you so much for joining us. We love your idea. We love the solution you are proposing. So our team, our jury members do have some questions for you. If you would like, you can take 1 or 2 minutes to add something to your presentation to what we have already seen on your idea.
Okay, first of all, I want to thank you all for the opportunity. It was a really interesting challenge to solve. Our solutions like addresses the growing risks from species migration, oil spills, and aquaculture damage, and extreme weather. These issues like threaten food species, ecosystems, and human livelihoods. So the current responses we are proposing, like our platform, shifts into a proactive early warning system. Thank you. Also, Michael is here. So
Michael Linzo,
Hello.
another team member, welcome.
Hello, good evening, everyone. I'm a software engineer, developed the project, and for the Blue Cloud Hackathon, we use data sets from eModNet API and Blue Cloud APIs in here. Everything from the data we use is also simulated, and most of it is from the Blue Cloud APIs. As we use the personal API because early in the hackathon we cannot have the O2. I'm having error of 500, but we use the personal API for the hackathon. And
right.
most of the, because today in the natural 2025 we have a lot of like storms like that. And recently in my home country in the Philippines, we had like a typhoon that was like devastated the local people, and with they had like to evacuate like that, the storm all over in the Southeast Asia. And with the proposal we're trying to give is that we can save lives, thousands of lives, from the early warning system using AIs and data sets. We can predict what natural events that can destroy families and lives. So we're like trying to save lives also, and also we're trying to save like corporates from, because in here in Qatar, my family work in the oil. Mostly in here in Qatar, the livelihood is in the oil industry, and we got like we had like used the oil spill monitoring like that and data, so we can prevent like natural disasters, natural events, and like we can plan ahead before these events, like this dangerous disaster, take place.
Thank you so much, Laura, and thank you also, Michael. I think it's super important to remember that the main reason we are all here today is the human life. It is what we actually want to improve. through all of this is what the scientific community, this community has been working on, and it's good to remember who we are doing this for. So yeah, putting that back into the conversation is really great, and all of our support and good wishes also to your home country. I'm going to give the floor to Dave and Othman now. And let's see what else they have to ask.
Go ahead,
Can I
Dave.
make a start? Okay, so yeah, incredibly ambitious program. Really, its breadth is enormous, and you know, it's great to see you willing to take on that sort of challenge. I have a question about the sort of at the core of your program is the use of AI. And the predictions made with your model potentially, as you point out, could save lives, or if you get the prediction wrong, maybe lose lives. Why should we trust a black box solution to give us an answer to make such decisions?
As our project, this early warning system, it's like a notification for our lives that when before a disaster strikes, we can like plan ahead, so we can prevent it from happening and save a lot of lives. And so also we can save our environment from preventing us from destroying our environments, and planning ahead, saving more, and doing what's more important for us, like human lives. And it's like early warning system, early warning detection. So it's it's really very helpful for a lot of people right now, with because a lot of calamities are happening all over the world. We cannot like predict it. Most of the modern tools we are using is like very erroneous and very like does not prevent us from doing like advanced planning ahead. But with this our solution and with our software, we can plan ahead and prevent these things from happening all over the world, not just from a region, but also with the big data that Blue Cloud would give us. We can do more and do plan ahead and have more data that we can use.
Okay. Thanks a lot.
Thank you, sir.
Thank you. So my questions is on a line of all the questions other judge has mentioned. It's the future plan from 3 to 6 months. What are your plans to do? If you win the prize money, what it would be allocated to? And what are your KPIs for this project?
Yes, from this from the event, from if we won the hackathon, we will use it development of the project more, and we will spread it with a lot of people, develop it more to the user. And since we have a POC only currently, we will make it more advanced and more simply that people can easily use, not just like nerds like me, but everyone that every people can use. And we will also like most of the development we will use, like make it more specifically used for every user, and every scientist also can use this one, since it will be more, the dashboard will be beautiful and simple, not very complicated and lot of labor, but we will use the most of the winnings for the development and also saving lives of people around the world.
Thank you so much.
Thank you, sir.
All right. Okay, I think there are no more questions. Thank you to all of you. I wish you the best of luck to your team. Dave, you can stay with us as the next team is one that you're going to be once again asking questions of. We have the EcoSea EO team coming up next. All right, part of Challenge 3, Tracking and Forecasting Ocean Health. Let's take a look at their video. All right, great. Thank you very much. We have with us Brian Vallejo and Tran Go. Thank you so much for joining us. And we also have Dave, who does have follow-up questions for your team. But please, would you like the floor to give us a couple of extra points on what it is that you're working on?
Thank you very much, Angeliki, Dave. So, well, the EcoSea EO is an idea that was born with the need to understanding how the health of the ocean can be monitored. We have been working with these systems for a couple of years, and we just noticed that all the data and all the things are available out there. So when we were going in through the documentation, we understood that the main activities that are causing the eutrophication or affecting the health of the ocean is mainly the wastewater discharge. So we realized that this Blue Cloud hackathon is an opportunity for us to create a platform that can help to monitor this state of the ocean and also link it with what the wastewater discharge location can affect. So, well, I'm happy that everything was successful and we handle a working prototype. So I'm very glad and looking forward to see the next steps with this. Thank you very much, Angeliki and Dave.
All right, thank you. Eutrophication is a topic that so many people are working on right now, so you're in very good company. Dave, please.
Great to read about your program, and it's a subject close to my heart. I spent many years working on eutrophication, particularly in the North Sea, but also working with collaborators elsewhere within Europe. Typically, we've measured eutrophication by making in situ measurements. You're relying, as I understand it, only on observations derived or made using models in order to calculate tricks. Is that correct?
Yes, that's correct. We're using different models, biogeochemistry, physics, and at the moment we have these non-gap models that we are using. One of the best advices we had was actually to do testing with the in situ data as well, but this is like a post-processing.
Okay, so how then, I mean, what level of uncertainty would you have with the application of models for particular areas within the Baltic, and how would you determine that level of uncertainty?
Well, that's a good point. When we were understanding this idea about how we can rely on those models, we realized that as we have a general view of the monitoring, we need to focus as well in the discharge points. That's why we are complementing with this data. So once we have the points where we want to understand, for example, when we go to the entrance of the Baltic Sea, we notice that we have different behavior of the tricks, is where we complement the analysis, understanding how the in situ measurements are affecting, how is the correlation with the model we have, because that's how we calculate the uncertainty, knowing how the model is actually predicting the real data.
Yeah, absolutely. You focused on wastewater discharges. There are other sources of anthropogenic nutrients entering our coastal seas. Have you considered those? And if so, how would you deal with those in the future?
Well, basically the documentation says the main cause. As you said, there are other ones. I think mostly depends on what the data is available and what the action is going to be taken. Because if the policy, if the institutions are focused on wastewater discharge, then we focus on that. But for example, shipping companies are also the ones that are affecting. Then we need to know what is the institution that is using our solution and what is in their power to take action. Maybe we may be focusing what is the power of our stakeholders to know what they can do, so then we can complement our product with what they can do specifically. I think actually this is a great question. If my workmate can also mention something, I would be happy.
Yeah, I can add on to Brian. So for the idea we take is from the Baltic state-of-the-art report from the HELCOM, and it states that there are three main pollution point, nutrient pollution point to the ocean. The first one is the wastewater treatment plant. The second is industry, and the third position is the aquaculture. So we decide to do the wastewater treatment plant first, And maybe in the future, we can also include the aquaculture, because I see in the Blue Cloud dataset, there's also data for the aquaculture operation. So that is the thing we can include in the future as well. And for the industry, I don't know, maybe it's too big data set, but we can try to, linking the pollution sort to the indicator better, with more data.
And the final question then, you talk about linking, as it were, the sources of nutrient pollution to the estimates of tricks. At the moment, that's just simply on the basis of geography. Are there any ways that you could, let's say, demonstrate the relationship between cause and effect, rather than simply using geography as your, as it were, evidence of the cause?
Yeah, I mean, something different than only visualizations, right? I think there are different techniques. One of the best ones is called the nearest neighbor, when you basically link the discharge point to the closest indicator. So let's say that every point of discharge has its own indicator of eutrophication. So once we start focus per location, we can understand a bit more precise how this discharge is going. But from my perspective, I would say that this is not the best solution. It's good, say something, but I would also increase the radius, like increasing a buffer or making an area or a specific section where the activities are happening and understanding a bit more in depth.
Okay, thank you very much for your comprehensive answers.
Thank you, Dave.
All right, thank you so much. Thank you, Dave, for the great questions, and thank you also for the great work, EcoSea EO team. We wish you all the best. And let's go to our next team. Okay, we have Blume or Blume team from Challenge 1, Mapping and Understanding Marine Ecosystem and Species. It is an AI-powered predictive model for sustainable fisheries called Maria. Let's watch the video.
Hi, we're Blume, a startup building ocean technology from Latin America to the world. Our solution is Maria, an AI-powered predictive model that forecasts tuna biomass and distribution in real time. Tuna is one of the most valuable species worldwide, but overfishing, rising food costs, and CO2 emissions from long and certain fishing trips are threatening both ecosystem and economies. Maria integrates environmental variable fisheries data and Blue Cloud resources like the Global Fisheries Atlas and Ecosystem Workbenches. And by combining this dataset with AI, it transforms complex ocean information into clear and dynamic forecasts. This means fishermen can find tuna faster, reduce unnecessary days at sea, cut emissions, and protect marine biodiversity. The impact goes beyond fishing. Regulators and NGOs get evidence-based tools for conservation. Coastal communities benefit from healthier stocks, and society as a whole gets more sustainable seafood on the table. We are testing Maria now during the Blue Cloud Hackathon, with a roadmap to scale it across tuna fleets by 2030. Our vision is simple: to turn data into action and make sustainable fishing a global reality. With Maria and Blume, we are not just predicting the ocean, we are shaping a future. Thank you so much.
All right, thank you as well. This is quite an optimistic project, and we need that in reality. With us, we have Oscar Miguel Castro Campos and maybe Raúl Caldeño Pazos from your team. But thank you for joining us, Oscar. We're going to have Othman and Mary with us for questions. Would you like to say a few words before we go to the questions, Oscar?
Thank you so much, Angeliki. Well, we are working on this since half a year ago, and basically we first focused on anchovy, that is a species that we catch here in Peru. We are from Peru, by the way, and the data set that we found in the Blue Cloud, it helped us to work with a more global species, that tuna. So we are working with different data sets, Blue Cloud, Copernicus, and another from other sources. So with that, we are recreating a visual map that that give probabilities of areas where different companies, different fisheries, different vessels can go and catch, and then we can monitor them. Also, not only help the companies, also help the government to regulate how is our ocean and how are the biomass growing up.
All right. Thank you so much, Oscar. As Ms. Emina Mamaca mentioned also in the very beginning, a representative from DG Research and Innovation, we are so happy that we see that that European data can be used in connection to other data that maybe is being collected in other parts of the world. So this type of interoperability is a great example that we are seeing through your team. I'm going to now give directly the floor to Mary. Please go ahead, and then Osman.
Thank you, Angeliki. Thank you very much, Oscar, for the speech in the video and also for your additional information presented right now. Just had a quite naive question. I was wondering what was let's say the initial need, your specific reasons to use AI to develop Maria. So your proof of concept in comparison to classic modeling solution, let's say. So what was for you the added value of AI for your project?
Okay, perfect. So right now we're creating different labels. The first label is satellite data, and this satellite data we are trying to create a relationship between different parameters to focus in the specific the ideal habitat of tuna. So the other one, the other label is the information about vessels. So we are not just focused in the satellite data, we're focused in the superficial data. And that gives us the opportunity to collect more in situ information. So with that, we are not processing few gigabytes. We are talking about terabytes. So with that in mind, artificial intelligence help us to process and give us more insights that we can do with other model. And also one label that I mentioned in my presentation is the robotics or the hardware. So at least in Peru, we don't have a lot of voice or a lot of sensor. But in our plan is to help to deploy with the governments these instruments that give us more information about the depth, different levels of depth. So with that with these three labels, we can have a digital twin of oceans, but digital twin of where tuna could habit.
Okay. Okay, thank you. Thank you. Interesting. Thank you.
Okay. Osman first and then Dave, of course.
Yeah, thank you so much. My question would be maybe coming from someone who would just try to simplify to the public. AI will give us a recommendation tool, but it's then for the fisherman or for the pilot to go with the decision that you make or not. How concrete do you think that your solution or your answer will be followed by the pilot of the ship or the fisherman? And if, for example, he decides to not go with your solution, with your fixed destination, how would your model learn from that explicitly? Yeah.
Okay, awesome question, Omar. Well, we've been talking about with some captains, some fishing companies, and they need more tools to get a more sustainable fishing, because most of them spend a lot of hours, sometimes a lot of days in the sea. So that is a risk not only for the people, that is working in the vessels. Also, they consume a lot of fuel that can generate a lot of CO2 emissions. And with that in mind, the fisheries will need to be more competitive, because fishing the fishing industry right now is not are not using other tools that the parameters that give us satellites. So it's a working in collaboration with this hackathon with governments, and to help us to help them to give them more information about the ocean.
Thank you.
And I want to add something else, is that when I talked with a camp time, he told me that most people don't want to work in the ocean, in the fishing industry right now. Most of the jobs are taken by young people that they don't know how to use the tools that are implemented in the vessels. We are talking about sonars, GPS. So it will be an industry that can be that if we don't help, will be destroyed, basically because we are not preparing more people with new tools, with more easier tools that give more information, more accurate information.
Okay. Okay. And I believe that you answered that question. Dave, would you have a question?
Just one quick question. I mean, tuna stocks are managed primarily through the use of stock assessment models to, let's say, prevent overfishing. How would your approach, let's say, compare? Would it be better? Would it be worse? How would you know?
Can you repeat the question? I didn't hear the
Oh, apologies. So there are tools that have been used by fisheries managers over many years to carry out stock assessments. Your tool would also provide information on abundance, distribution, and therefore could potentially replace existing stock assessment tools. Do you think it should, and why?
Well, that is a thoughtful question, Dave.
Sorry.
Well,
apologies. It's not an easy. Yeah, I apologize. It is a tough question. I agree.
Yeah. Oh, maybe we're trying to build. We're building a tool that will help to fish more sustainable. We're not talking about destroy other company that are helping. Maybe we can collaborate with that company, Dave. We can collaborate because they have data. We have the models that we are working on, and with that in mind, it can create a more potential model that help us to not only fish tuna in a sustainable and efficient way, maybe other different species like anchovy, like I told you, that we are working on Peru. Well, in English, for me, the species have different. But
no, to help you out, I think what you're doing is very interesting because you have the potential to really embrace the concept of an ecosystem-based approach by drawing in, let's say, a wider range of data. But it is a huge challenge. Doesn't mean you shouldn't do it, but thank you for your answer, and I'm sorry for putting you on the spot.
Thank you, Dave.
Thank you. Thank you. And we want ambitious ideas. That is a very important thing after all. And, you know, if you have them, why not make them ambitious? I'm going to thank all three of our jury members. And I believe that with this, we have seen all 10 of our finalists. This is the moment that Michele and our jury members are going to leave us. And they are going to go and do the final deliberation while you were all presenting. They've already started applying. Some of they have been applying already scores, and yeah, they need to group together, and when they will come back, we will know the winners. Now, I would like to continue with inviting Sara Pittonet to please join us and open her camera. Again, I mentioned Sara in the beginning as well, and Sara has also given us an amazing presentation during our first live session on Blue Cloud Hackathon resources and the Blue Cloud Project 2026. And she has prepared a great presentation that has a bit of an overlook of the resources that you guys were using, etc. It's super interesting. And please, Sara, if you would like to share your screen.
Yes, thanks a lot, Angeliki. Actually, what's amazing is what I've seen in the latest 2 hours, honestly, not really my presentation, because all of the things you presented are really super valuable and interesting. And that's really great, because I've been following the hackathon let's say proceedings and works online over the last 3 days, and actually I've gathered in these slides a little bit of what all of you and the other teams have published on our social media channels, and in particularly this is an overview of the LinkedIn post that you've published with the hashtag Blue Cloud Hackathon. And I mean, it gives an idea of the possibilities that we are giving you thanks to these research infrastructures, and of the great ideas that you're pulling together. So I've gone through them over the last days, and of course you've presented quite a lot already, but I mean, we have ideas that span from fighting against plastic. There was a jelly guard, which I liked a lot. I mean, I'm not part of the jury, so I'll completely neutral. A tuna distribution service, services for mapping sea surface temperature and water. We've seen the oil spill trajectories, impact modeling. We had one turning square pegs in maps into currents, round currents, or the octopus larvae modeling. I think there are a couple around octopus. Biodiversity records monitoring a lot. A tool to help manage food waste on land. Early warning protector system ideas. Applications to map fish movements we've seen, or alert systems for fishery producers. So it's really rewarding, I say, seeing so much happening in 3 days. I mean, because you've done all of this in 3 days, okay, a little bit more if you consider the entire time frame. But actually, you did that in a relatively small time series. And that's exactly what we need to see, because the colleagues in the Blue Cloud project have been worked over the last 2 years, but actually is much more, I would say, started back 5 years ago, to build these environments, offering you different amount of resources. And now these resources requires users. And that's the stats that I'm going to show you today, because I opened the hackathon on Monday by asking you to be our testers and test the resources that we have, give us feedback, because this is what we need from all of you, and exactly what happened over these days. I wanted to give you some figures in terms of access to the resources. So over the last days, we had 125 active users and 344 new users, more than 5,300 sessions. Sorry, I spotted some Italians in the text, which I didn't translate. but more than 3,300 sessions in the V Labs and 854 sessions on Jupyter Labs, so notebooks. You had the possibility to test the 5 virtual labs, the workbenches, and to couple it, the services there with the editor services. And it turned out that the most used virtual labs are the marine environmental indicators virtual lab, the ICOE one, the coastal ocean monitoring one, the coastal currents from observation virtual lab, and the global fisheries atlas. In general, the technicians working behind the virtual research environment of Blue Cloud confirmed that we had peaks in all our metrics, from sessions to number of calls, notebook usage of our studios, and we received a lot of feedback. They're not all just positive. I mean, we received also comments that will help us improve the services and the workflows and how the access to the resources is provided. And we are taking them all into serious considerations. And this is the overview of the usage of the resources it gives an overview of the last 2 years. So the first graph on the left is what I presented in terms of new users. So this peak here is this last week, basically last 2 weeks, where we had the 400 increase in the number of users registered to the Blue Cloud VRE. And the second one gives the idea of the accesses to the overall environment, including all the virtual labs together. Here are the virtual labs that we saw has most used. And below you see the map of the geographical provenance of these users, which confirms that of course, Europe is our primary region of interest, being the project European, the primary stakeholders are located in Europe. But we're glad to hear that there are users outside Europe. I mean, even in today's presentation, so in the finalist group, there are people working outside Europe. You've heard from North and Central America, or from Eastern countries, Philippines and India in particularly. So very glad to see there are no bandwidth and boundaries with respect to the usage of this virtual infrastructure. And here on the right, it's the usage of notebooks mainly, so the production of the exploitation of the notebooks from countries. And you see, I mean, here is evident, I mean, that you have been working a lot, as well as the exploitation of the RStudio services. And then, so while we wait for the results, I want to anticipate that this is, of course, not the end. So Blue Cloud project it will continue until June next year, sorry. And it means that we hope you will continue with us with two meanings. So the winners of the hackathon we know the best three will receive a prize, a monetary prize. But it was not by chance that the jury members today asked you, what are your plans for evolving or the services, or for further uptaking the services, because this is exactly the way that we want you to go. And that's why we're also providing some monetary support. We won't, of course, change your lives, but we hope that this will give you some effort to evolve your services and look a little bit longer in your business plan and show this with us again. And there will be some opportunities for you to show your services, your ideas, or your running pilots. The next one is very short in time. It will take place in November in Brussels. it's the third of a series of workshops that we have called Federation Workshops, because as Emina, the DG RTD officer, said in her opening, Blue Cloud is an open science project, and we aim at bringing together people, so the community and the services that can help us address broader challenges that our oceans face today. And that's the idea of this federation. So we bring together different initiatives and we try to find connections, overlaps, and a way to collaborate, in particularly under the umbrella of the European Open Science Cloud program, where Blue Cloud is active, and where Blue Cloud is also playing a prominent role, being now the candidate node into this federation, the candidate node for marine research. So we will welcome many of you, we hope, into this workshop, where we have a specific session during the day. I mean, actually, it's the big part of the agenda dedicated to showcasing these services. And the agenda is taking shape exactly because we also wanted to wait for this hackathon to invite you to submit ideas and come to Brussels and present them on the 6th of November. So here is the link to join, but then we'll follow up with you also with some direct emails. And with that, I think I'm done and I've said what I wanted to say. So not sure what's the timing now for our jury to.
It is getting there. They're working on it. Let the drums roll, indeed, Sarah. It's going to be happening very soon. It's so many things that you said in your presentation, but I think that the main point has to do with seeing how well the tools of Blue Cloud were used. And as you mentioned, the feedback is so important because, of course, we're always happy to receive positive feedback, and it makes the people who create this type of tools, it's a long process and a lot of work, so it's always great. But of course, also hearing the negative feedback is the only way that in the end we can actually improve. So it's all welcome. And again, we've had a great balance because we've had some really great things about how useful participants found the tools. And I'll take the opportunity to mention that another survey is going to be sent out to all the participants. And it would be great if you guys could take a little bit of time to fill it out and send it back to us. We take your feedback very seriously. This is information that is being passed around in our community to see how we can improve overall everything that we are creating, of course, for all the users. We are now going to pass to another favorite part for me in this hackathon. Sara also mentioned it. Let me quickly share my screen. Okay. So we had 2 mini challenges. One was the data in a picture, where we asked you to capture a screenshot, graph or map from the Blue Cloud 2026 platform that amazes you and share it with a one-sentence explanation. We also had a second mini challenge, the Ocean Pledge, where we asked you to share a personal action you'll take to protect the ocean, inspired by something you discovered in Blue Cloud data. It was really hard to make a selection. The posts were simply wonderful. I too made a slide on this topic. If it was possible, to be honest, we would probably have had something like 7 winners in each category, even though all of them were wonderful. But we had to eventually go with some finalists and, of course, choose a winner. And we are going to also share the winners' posts with some dedicated thank yous for it. And we chose on a variety of various the basis for our choices comes from different aspects. It had to do with passion. It had to do with some really good calls to action that some of you included, etc. But again, just to make it very clear, we loved all of them. So for challenge one, we had some finalists. The first one was by Leonardo Tronci from the Jelly Guard team. They were in, they think they were in challenge two. And together with their teammates, they explored the Blue Clouds Marine Environmental Indicator Virtual Lab to identify key parameters affecting jellyfish blooms, to configure specific analysis of the Italian Mediterranean, and to generate real-time climate maps. The data that they process will power early warning robotic system to protect coastal areas and marine ecosystems. Their goal, creating sustainable technology that combines data science and robotic engineering for ocean conservation. So the topic we liked very much. The data in a picture, the way that they presented it was great. And everything was super clear in this post. So it was one of the favorites. Then we also had someone from the team we have already seen. It is here with us in the finalists, the 10 finalists, the Smiley axolotl. So Eric's from their team. He gave us a great data in a picture example. His statement is, I never imagined that North Sea floor was so densely carpeted with plastic bags until the Blue Cloud Hackathon troll data map laid the truth bare. Time to act. It's not always about how long the post is. We found that in 2 sentences there was so much passion in there. So definitely also deserve to be in this group. And then the third finalist for this category came from Ingenium Immensa. This heat map from the editor platform reveals that over 14,000 tons of plastic in the Mediterranean mainly come from European coastal and river sources, inspiring Team Ingenium Immensa to integrate such environmental insights into our food scoring system for more conscious, sustainable choices. Thanks to editor, European Digital Twin Ocean, and Blue Cloud 2026 for turning data into impact. There was a combination of everything. Of course, using an image from editor was incredible, but overall, also again, it's the sentiment, etc. And plastic is a huge problem. It's a huge issue that again, so many people around the world are working on, and we thought again it deserved to be in the finalist list. And let's now. Sorry, I'm not sure. Yes. Okay. I believe we have been joined. Okay. And this is the final mini challenge one winner, the data in a picture. The prize goes to Leonardo Tronci and his team, Jellyfish in Action. Leonardo, I'm so sorry that you were not in the finalists, but we're very glad you participated in this challenge, and we'll make sure to highlight your data in a picture post through our social media. Thank you again. And now we go to the second mini challenge, where we heard from Molly James. Okay, I think that Molly James also is from one of the finalist teams, Kraken the Code. That post said, after seeing data showing how octopus larvae rapidly propagate between France and the UK, I'm struck by how deeply interwoven our ecosystem and our responsibilities are. The sea doesn't recognize borders, and neither should our efforts to protect it. This data has been collected through the Blue Cloud 2026 Hackathon, and as part of the work of our PML team, Octopulse are doing here. Our pledge is to advocate for cross-border marine data sharing, supporting collaborative conservation policies that reflect the true fluidity of ocean life. So again, this has so many great messages in there. And of course, as you said, Molly, the sea indeed does not recognize borders. And this is something that is currently there's a lot of discussion. And then another finalist was DeepZ, Victoria Mikalaska. As a member of the DeepZ team during Blue Cloud Hackathon 2025 and an open water diver, I take the ocean pledge. As explorers above and below the surface, we pledge to protect and respect the ocean, our planet's life source. Through science, technology, and first-hand experience as divers, we commit to making marine biodiversity visible, accessible, and understood. By sharing knowledge on species, habitats, and climate impacts, we aim to empower others to care, act, and safeguard the ocean for future generations. I think no more words needed here. It was incredible. And finally, our next choice came from Lotte Paul and TwinTrack, another finalist team. From catching and tagging fish in the field to now mapping their movements and co-developing an application with Blue Cloud 2026, I'm experiencing the full circle of how data can connect science, people, and decision-making. My pledge, I will continue to advocate for a reduction in seafood consumption and share insights from ocean data so that more stakeholders can make informed choices for a healthier ocean. Every action from fieldwork to fair and open data can ripple outward into meaningful change for our blue planet. Again, it was just beautiful. And we will be sharing a lot of these through our channels. And finally, the winner for this category was Victoria Mikalaska. It is a wonderful thing also to hear from the diving community. There's a lot of work currently being done in connection to citizen science. So you guys are invaluable piece of this ecosystem, and we look forward to seeing what we can do next. So these were our winners. We do hope that you enjoyed taking part in these mini challenges during the hackathon. It was meant to give you a bit of space, to take a moment and be creative on something else. And we really appreciate your effort. So with this, I believe that our jury members are back. I believe that we have final decisions. I'm going to stop sharing my screen and allow Michele Erba to share his. And before we go to the announcement of the winners, I would like to invite our coaches and mentor team as well, who are here to join us, to open their cameras so we can properly thank everyone. Because again, these were the people who were supporting you for many weeks. They were the ones that prepared and updated all the tools. We are very grateful for that. I'm not sure how many we have with us, but we would like to thank you so much. Matteo and Julia, Francesco, Marco, Rafael, Joao, Pasquale, Felix, Enrico, Bastian, Osman. Well, okay, I'm right back. So thank you so much also for being here to see the results of it's in essence, it's really your work that we are celebrating here today. Please stay with us. Do not close your cameras as we announce the winners. We are just for a moment going to take a look at the prize pool again. Thank you, Michele. All right. Here it is again. As Sara has did also, of course, go over it, so we're not going to stay here for too long. We do offer the financial support up to 25,000 euros. It was part of this process also to see how you're planning on using it. I don't know if Sara would like to make a point here as well.
No, I mean, we will follow up later,
Okay.
I mean, with the successful applicants with some more details.
All right.
I mean, it's a matter, as I said, of evolving, so using these resources to evolve the services and give them some visibility.
Great. And they will get a lot of visibility also from what we understood from your presentation during their trip here to Brussels at the event in November, which is going to be very, very good for all the teams to be exposed to other stakeholders and others who can also possibly continue supporting them. And finally, of course, we're going to be giving some editor access. It is not it's not the part of exclusive access, because editor, of course, also is meant to be a public platform. But while we are working on a variety of features, etc., there, of course, in order to get onto the platform and the work, it is something that you need to be doing with the editor team. So as a lot of you saw through this hackathon, it's an incredible tool, and a lot of you used it very, very well. So it would be a great thing to be able to continue using it after this hackathon as well. So we're very, very happy also with the prize pool. Okay, so I think that it's time that we start announcing our winners. Okay. So we are going to start with Mary. Mary, please open your microphone.
Yes.
Okay. So tell us. So we are going to have, I'm sorry, just to mention again, 3 winners. There's no first, second, or third. All 3 are equal winners in this hackathon. All 3 teams that were chosen had equally great ideas.
Okay.
All right. So Mary.
Yeah, so the winner I'm happy to announce is TwinTrack.
TwinTrack.
Congratulations.
Congratulations. All right. That's excellent. Okay. And then Dave, please. Who is...
Well, it gives me great pleasure to announce another winner, and that is Kraken the Code. I'll just say a few words about that. I thought it was one of many great projects that were presented. What stood out for me, apart from the wonderful name, was of course the wider engagement, the commitment to an open knowledge system, and the true interdisciplinarity of the project, drawing in users and creating a transparent capability to address, yes, a short-term challenge, but with the potential to roll that out much wider, and particularly embracing the concept of the co-production of knowledge. So well done, great project. Look forward to seeing how it develops. Thank you.
Thank you. Thank you so much. Congratulations also to Kraken the Code. And Marco, please let us know who is the third winner.
The third winner, I'm very pleased to announce, is RugOBSS.
Oh, congratulations. Congratulations to the team RugOBSS as well. We would like to invite also the representatives of the team to join us. So if we could hear first from TwinTrack. Again, congratulations on your win. I think Lotte and Christopher are with us. Lotte, would you like to say a few words?
Well, I'm blown away at the moment. Thank you so much for this amazing opportunity, and yeah, we're super happy, of course, and grateful for being able to have participated and now taking our project to the next level, really, just because of the hackathon. Thanks, everybody.
Thank you so much for all your hard work. Thank you so much. We look forward to seeing what you guys do next. All right. If we could now hear a little bit from, I think it is Molly, James, and Benjamin.
Yeah, hi. Thank you so much. Yeah, it's been a wonderful opportunity, and we've really enjoyed it. It's going to be great to develop this further. Ben, I don't know if you've got anything else to say about it.
No, I just echo your thoughts. Thanks to everyone, and thanks to the judges, but also thanks for the technical staff who designed and built it. Well done.
Congratulations to the whole team, guys. All right, and let's hear a little bit from RugOBSS.
Yeah, thank you so much. I think it was a wonderful experience, the whole hackathon, and we were not expecting this. But yeah, one of the things that we are lacking the most is this financial support to keep growing the algorithm. So we need a lot of field work to keep feeding the algorithm and blending the capability of the modeling. I think it's going to be fantastic. Thank you.
Thank you all very much. This was a great experience for us as well. Michele, if we can stop sharing, I think, and if we can just bring back a view where everyone can see our team. We have already spent 2 hours and 2.5 hours almost on this award ceremony. It was an incredible experience for everyone. Abel, hello. It's okay. It's okay. This was another great coach that I believe some of you did connect to. So we would like to once again thank DGRTD for their support. We would like to thank all of our colleagues from the editor team for their incredible support and for preparing your access and giving you tips throughout this process. We would like to also wholeheartedly thank the team of Blue Cloud coaches and mentors. Your dedication to this process was great, and it helped us really organize a very, very good and tight event. I would also like to take the opportunity to thank once again Michele Erba and Pristine Agency. Without them, it would have been such a wonderful and organized event. So Michele, once again, thanks for your hard work.
Thanks to you guys. It's been a pleasure. I'm gonna get some rest. I'm gonna go to the mountains tomorrow. I'm gonna go back on Monday. Okay, if that's okay with you.
Well deserved. I hope that your guys get to go somewhere. So with this, I believe that we are going to let you go. But again, thank you to also every team that participated. I think that you have great ideas. We would like you to continue working on your ideas. If I did not do that before, I would once again and for a final time like to also thank the jury members. They worked hard behind the scenes at strange hours to get our teams here. I would also like to thank Elisa Ravangan, who couldn't be with us today. We send our wishes for a quick recovery. Thank you, and we hope to see you next time. All the best to everyone.
Thank you, Angeliki. Thank you all.
Bye, everyone.
Thank you all.
Bye-bye.
Thanks a lot.
Thank
Bye.
you.
Bye.
Thank you.
Bye-bye.
Bye.
Thanks, Julia.